Good afternoon, everybody, and thanks for coming. My name is Judd, and we're going to talk about enterprise observability with OpenTelemetry today. So a little bit about me. I am the CTO and a partner at Manifest Solutions. Don't let that scare you in any way, because what it means is I'm a consultant. So I go out to our client sites every day, write code, architect solutions, and you're going to learn in this story I'm about to tell you that I often have to fight fires as well. I'm a Java champion. I'm also John Maxwell certified as a speaker, trainer, and coach. And when I'm not writing code, I tend to write words. So I've co-authored some computer books, and I've also written a children's book. So now to that story. About 2 years ago, I got called in, which I commonly do. You know, I rarely get called at the beginning of a project when things are great and under control. It's always, you know, when something's going bad, I tend to get called. So I got called for this client that I had worked on other applications for, but never this particular one. And I think it was probably because I made a mistake earlier by drawing up on the board all the components involved in their architecture. And the manager said, "How are you able to do that from memory? I've been asking for 2 years and nobody's given that to me." And so I got called in when there was a performance problem. And I asked, well, how do you know there's a performance problem? Well, our biggest customer, of course, it's always the biggest customer, is experiencing performance problems, and it's their busiest time of the year, and this is the worst time for those types of performance problems. But the interesting thing is, it's only happening to one customer, not all the customers. And knowing this type of system actually happened to be almost 95% read-only data, I was like, well, that's really unusual because it's all coming from the same data source, and no particular customer would have a significantly different experience. So I did what I always do. I started looking at the things that are under our control. So the things in the box from the F5 to the right. You know, is it something in the database? Is it something inside of the app server? Is it something at the API gateway? And I started measuring what I could. But what I quickly found out was it was very challenging because each layer had a different way of logging performance, dealing with performance issues, timing of things, there was no correlation between any of them. But what I quickly realized, you know, we even went as far as at the F5 layer dumping PCAP files to see, was it happening inside of our infrastructure or outside of our infrastructure? And it became apparent that everything inside of our system, except for maybe one endpoint that was running about 3 seconds, which was pretty normal for that endpoint, everything else was significantly sub-second performance issues. So then we had to start looking outside of our infrastructure. And that story of not being able to correlate anything got even worse because we had to go through a WAF. And that WAF was a commercial software service provider, and we had almost no visibility into that. I eventually did find some documentation where if you put a certain header on for 5 seconds, you would get some performance measurements coming back to the browser as header information. But of course, our end users couldn't really decipher that. And then we looked at what's inside the customer's infrastructure as well. But what we ultimately narrowed it down to was it was something inside the WAF. Even though the WAF was reporting all of its mechanisms were performing sub-second, we had eliminated everything on both ends. And so we called up the WAF provider and we say, we really think you have a performance problem in your infrastructure. And you're probably asking yourself at this point, well, why would it only affect one customer? Well, we learned through this process that they actually had WAFs distributed in multiple regions. And because of that, we were getting one particular region that was servicing this customer that happened to be the bad one. And they kept on coming back and saying, it's not our problem, it's not our problem. And finally, after a week, they said, you know what, we did find one node in our infrastructure, so too bad they weren't using OpenTelemetry as well. We did find one node in our infrastructure that we rebooted. Can you check again? And the performance problems were gone. But this literally took multiple weeks during a really stressful time to come up with the solution, and then they did not even involve me till after, you know, the first week. So, had we had observability in place, this would have been much easier. And so what is observability? Well, observability is the ability to measure how well internal states of a system can be inferred by knowledge from its outputs. And so what does that mean? That means we want to get information out of our running systems and use that to determine the health and the performance of our systems. I kind of think about it like a couple of years ago when my son broke his arm. To determine if he had a broken arm, they first started feeling it, and he said, that hurts. And then they said, well, let's get you an X-ray. They didn't grab a scalpel and immediately cut open the arm to determine what the issue was. So they were using those outside signals to determine what was wrong with his arm. In 2016, Twitter put out observability pillars that they use, and they focused on monitoring, alerting, and visualizing. So alerting being notifying people when there are problems, tracing, distributed tracing across all their components in their infrastructure, and then ultimately aggregating all the logs from their microservices in their infrastructure and performing analytics on that. Now the industry has kind of gotten around behind some general observability pillars, and those pillars primarily focus around distributed tracing, which was one of Twitter's, metrics, and then logging as well. And I think you're going to find out here in a little bit, ironically, that's also what OpenTelemetry focuses on. So what is the word telemetry and OpenTelemetry? Well, that's be able to gather metrics from remote locations. And I actually love the Greek where it came from, which is tel for remote, and metron, which for measurements. And I think the easier way to think about this is in an IoT environment. If you have lots of sensors, you're gathering the data from those sensors, whether they're being temperature sensors, humidity sensors, across multiple locations. Well, in our case, those multiple locations, those sensors, are actually built into our applications in each of our microservices. So we're getting them from our microservices, our F5 servers, our databases, and then we're all aggregating those into one location. And what types of things are we going to gather with software telemetry? Well, we're going to gather things like performance things. How long does it take to process something? How long does a particular method or library take? Are we having application crashes? Do we have a large amount of exceptions going on or errors? Just general usage statistics. So when a user goes from one page to another page, how often does that page get used? We have features. So are they using the whiz-bang new feature we put in? Are you able to do A/B testing with this? User behavior. Do certain users use the application at certain times of day? One application I worked on, during the week, we got all desktop browsers, and on the weekend, it was all mobile browsers. That can be important to know, and that particular scenario was for crew or rowing. So on the weekends, they were actually at the lake, at the river, watching the events or participating in the events. But then during the week, they were at work, probably on work time, checking out what the upcoming schedule was going to be. Hardware statistics, how much memory we're using, disk space, things like that. And I wish I had $1 for every time we ran out of disk space, even though there was monitoring on it. And then finally, another important one is security. Are we doing any type of threat detection or investigation to determine what attackers may be doing against our systems? Now, there are tons and tons and tons of software as a service that meets this need, both commercial vendor products as well as open source. So the first two columns here are all commercial vendor products, and the far right-hand column is all open source solutions to this. Now, spoiler alert, OpenTelemetry does not replace these. It works in conjunction with these, which I think is the big advantage of it and why it's being adopted so quickly. So let's talk about what are some of those challenges of why we might need something like OpenTelemetry. Well, what I've seen oftentimes is different pieces of software, whether you wrote them, they're commercial products, whether they're from a SaaS provider or your cloud provider, might use different tools and technologies for gathering this type of information, the distributed tracing, the logging, and the metrics. Well, by nature of them being in so many different disparate systems, it's hard to correlate those. What I've also come to realize is most organizations I go into, they have zero tracing. But if they have attempted it, they probably had Zipkin at one point in time that they actually didn't fully get operational or see the value in and ultimately turn it off. But you can see those little breadcrumbs that they left behind. So this is trying to demonstrate, like if you're using a cloud provider and Lambdas, it's probably going to CloudWatch. Maybe an API gateway only knows about Jaeger, while you wrote your application to know about Zipkin and Prometheus, and then other things might not talk to anything that you can collect OpenTelemetry or any type of telemetry from as well. So you have no observability into it. And this is really getting important now because our systems are getting so much more complex. So a user makes a request that can go through an API gateway, talk to a microservice, it might talk to another microservice, it might talk to a Kafka topic that talks to a database and maybe a NoSQL database. So our applications are getting so complex, we just really require this visibility into our systems. And this is where I think OpenTelemetry comes in and helps solve the problem. And OpenTelemetry is a 100% free open source solution that is provided by the Cloud Native Computing Platform. And what it really is a combination of APIs, libraries, and agents that can be used to collect the telemetry data, specifically for metrics, logging, and distributed tracing. And it's going to collect those for us. It is not going to provide any type of user interface to us, and we'll see what we can use as we go along here. Now, OpenTelemetry has gotten a lot of buzz lately. You're starting to see a lot of conference talks about it. Some books and other documentation is starting to come out. And you might be thinking, well, this is a pretty new, young project. But the reality is, it's been around in a flavor of one sort or another for several years now. What happened were two separate projects, Open Tracing, Open Census, came together and combined to produce OpenTelemetry. So right from day one, OpenTelemetry already had a code base that was usable, functional, had been battle tested. Like I've said before, there are three things that OpenTelemetry is hoping to collect, and I've used some opacity here to show you what states these are in. So right now, distributed tracing is considered done from both a specification level as well as an implementation level for most languages, including Java. Metrics is done from a specification level, but not all the languages and libraries have it implemented at this point in time. Java is one of those where it is implemented. And at this point in time, they've done nothing for logging. So that is to be done in the future. They figured that was the one they were going to save for last because that was probably the most mature in the industry up to this point in time. So we're going to focus on distributed tracing and metrics here and not talk about logging because there's nothing to really show at this point in time. Well, that wasn't supposed to come up that fast, but okay, so let's talk about what is distributed tracing. So think about a transaction, and not necessarily a database transaction, but more of a business transaction. A user comes to a website, they want to purchase something, and they click the buy button. What are all the components that need to happen for that to occur? Well, if we traced all that, you can almost think of it like a thread. If you were talking about a monolith, it's going to go to a bunch of systems, and we want to know what systems it touched, how long it spent there, what did it do in each of those systems. So we are going to take this example here where we have a browser talking to an API gateway that is going to talk to something for security. It's going to call some microservices, talking to a database, maybe another microservice talking to a NoSQL database. And we are going to draw a waterfall chart, basically, of those interactions. And that's going to be called a trace with spans. So each amount of time that it spends in those individual components would be a span of time for that trace. And then on the metric side, we're going to be talking about metrics. And so you've probably been capturing metrics through JMX or maybe through Spring Boot's actuary. But it's going to be some type of number associated with something. So this happens to be garbage collection pauses, and specifically the number of times, the total time it spent, and the maximum time it spent in those in the pausing of your garbage collection. And now we're going to see how that is all implemented inside of OpenTelemetry. So the architecture for OpenTelemetry looks like this. There are several components. We're going to walk through each of those so you understand what is available to you and how you might take advantage of that. At the very top, we see that we have some semantic conversions. We also see we have some APIs for tracing, context, and meters. So all of this API is the specification that multiple languages and libraries can implement. And then those semantic conversions are able to convert it from one protocol to another protocol. And all of this is just defined inside of a language independent protobuf interface, so it can easily generate all those languages. It also defines in there a protocol, which is the OLTP protocol, the OpenTelemetry protocol. And so when I say that distributed tracing and metrics are defined, it means that at this level they have been fully fleshed out. They think that they're production ready to be used. Next, we have the SDKs, or the libraries. And what I've done is I've put the logo for OpenTelemetry next to the things that there are things to download and actually use and install in your systems. So at the SDK level, we can see it's broken down, and we're going to look into some of those details later about the tracers and the meters. But on the right-hand side, you see that we have these SDKs implemented in most of the popular languages that are probably being used out there today. So you would potentially download a jar file and include that in your Maven dependencies. So Maven would download it for you, and now you would have that library embedded in your application. We also have a collector, and this collector is going to run as a separate process, oftentimes as a Docker container, receiving that information. And we can take advantage of this for scaling, and we'll look at that in a little bit more detail in a minute. And then finally at the bottom, we have vendor implementations. And so, as I mentioned before, we're not replacing any of those products you might already have today to handle the details for collecting, tracing, or metrics, but you can use this to help augment that. And so you can use the products you have existing, or you can introduce new ones easier by using these mechanisms in OpenTelemetry. And then finally, it is super, super flexible. There's a lot of different extension points, and we're going to look at a couple of them, specifically the span exporters, the metric exporters, which you can see both in the SDK and down in the collectors. And these can export to things like Kafka. They can do protocols of common open source libraries like Zipkin and Jaeger if you're already using those. It can also use log to the console as well, or ship it to any of these vendor systems you might already have in place. So this might look like the same slide as I showed you before, but notice the title has changed. These are actually all the supported ones today, and more companies are joining this bandwagon because they see the value of OpenTelemetry, and they'd rather see us as application developers utilizing this rather than fighting over which tool we're going to use. And it doesn't mean we're limited to a single tool. So if you are using any type of observability today, you are probably using a library that you have embedded inside your application. So I've shown here the examples of Zipkin and Prometheus, but it could be a commercial product like I've done a lot with New Relic, for example. You would embed those libraries or an agent on that machine. Well, one of the advantages of OpenTelemetry is instead of having those inside of your applications, you can be dependent on just the OpenTelemetry libraries, the SDKs that we talked about, and you've abstracted yourself from the underlying implementation. So I like to think of this kind of like as JDBC or SLF for J. You don't want to hook yourself to a specific database or to a specific login library. Why would you do that for your telemetry data as well? So now we'll have a single vendor, a single open source library that we can have talk to any number of vendor products, which I think is super advantageous. Also, and I think one of the reasons there's so many people on the bandwagon is I don't think all those vendors want to write a library for each language and have it collect the same data. Actually, it kind of reminds me a lot of when we had the JSTL come out, and each MVC framework used to write its own tag libraries. And they said, well, we're all doing the same thing with looping and stuff. Let's have a common one. I think that same feeling has come out about collecting telemetry data. One of the other advantages of this over what I've seen implemented with any of the other products is we can scale it a little bit easier. That collector can run as either an agent or as a gateway, and by doing that, we can scale. So you have both the library that can be embedded, and you can talk to an agent that is running like maybe on the same Docker machine or the same host as the applications, and that would be in an agent mode for the collector. But then you might want to collect at a regional level for scalability, and then you would use a gateway for that. And ultimately, all that data going to either the agent or the gateway, or directly from the library if you choose to do this, can then be routed to any number of products that can handle that data. And so you're not limited to one. You could have it go to both Zipkin and Jaeger, even though they do basically the same thing. And this gives you a ton of flexibility too, because what happens if tomorrow they come out with a really great machine learning, artificial intelligence solution for detecting intrusion? Well, you don't have to change your application. You change the configurations in your gateway, and now it's going to a fourth system. So it can be really flexible in that way. You're not limiting yourself. All the communications between the libraries and the agents are going through either OLTP, which is their internal API. It can go over gRPC, it can go over HTTP, so there's a lot of flexibility on protocols as well. It also understands Zipkin, Prometheus, and Jaeger as protocols because those have been so popular over the years. So I'm going to start doing some demos in a couple minutes, but just to give you a little bit of the lay of the land of what I'm doing for the demos, instead of writing my own application, I'm taking the Spring Pet Clinic application, specifically the version that uses Angular as a front end and Spring Boot as a back end using REST services. And so we're going to have an Angular app talking to a REST, which is actually talking to an HQL DB. So we'll have multiple things running. I have some great news for you. For Java and most libraries, there is some type of already existing instrumentation library for you. So these instrumentation libraries are open source, and all you have to do is include them the right way. In the case of Java, it's a Java agent, and what it's going to do is weave in all of the points that are common in a Java application you might want to gather, such as anytime it talks to a database, anytime it makes a REST call, anytime it talks to Kafka, even within the same application, as you're going from controller to service to data access to Hibernate to the database, JDBC, it can capture all of those spans as well with really no configuration on your behalf. So what I'm going to demonstrate here with the REST service is using the library, and I'm specifically going to use an exporter initially called the log exporter. So instead of sending it to a another collector or to one of the vendor systems, it's going to actually just write it to the log. And so it's all documented here on the log exporter. And it's super easy to do. So I'm going to do a Java agent. I'm going to include the most current OpenTelemetry Java agent jar. And then I can configure whether I want both tracing and logging. So I'm going to enable tracing, telling to use the logger exporter. And then I'm also doing the metrics as well and configuring that to the logger. And then just specifying my jar like I would with any other Spring Boot application. And when I launch this, we can see initially it says, hey, I found the agent. This is the version of the agent. And my application starts running. And if we wait here for a couple minutes, we will see that every, I think it's 5 seconds I have it configured, it's going to collect metric data that it's going to spit out. And if I go to my endpoint, which I'm going to use Swagger UI, I'm going to go down to my pet endpoint, and I'm going to get all of the pets. And if I go back here, we can see it printed a bunch of stuff out, starting with OTel, which is the abbreviation for OpenTelemetry. And it tells us that we've ran a bunch of select statements, done a commit. And since this is a little hard to follow, I've made it a little bit easier here by highlighting some things. So we can see it ran, and this is going to be in reverse order that you would think of. So this is from right to left. So it ran a select statement. It tells you what select statement it ran. It ran another select statement. Here's the select statement it ran. Those were captured by the OpenTelemetry JDBC. And then down here we have another select statement, or sorry, this isn't the select statement, this is actually at the Hibernate level. So Hibernate knew it was going to run a select statement. And then we have at the Spring Data, JPA, DAO, repository level, we are calling a find all. We committed a transaction. We called an endpoint in our Spring MVC of list pets. And then here is the actual endpoint that triggered the whole thing at our REST endpoint at the Tomcat level. And we can see all the common stuff we'd want to see from HTTP, the user agent, the response codes, things like that. All of that without writing a single piece of code, without actually including a library in my project whatsoever. Now this might seem really simple, but there are times where you just want to find out when this call happened, what were all the database calls made? How easy is that to find out that information really quickly, as opposed to having to configure one of those jars that log it or change your property file and accidentally goes to production, and now in production you're logging all your SQL statements. So this can be a really nice debugging tool even locally just by adding that agent jar in. From a metric standpoint, we can see that we are grabbing the database pool information, the number of connections, the JVM information with the CPU utilization, Tomcat information, and more HTTP request information. And all of this is also including a correlation ID, so we can tie these numbers to our data related to our tracing as well. Now this logging solution you're probably not going to use in production. What you're really going to do is you are going to take advantage of your collectors. And so this is a diagram that they use for collectors, where you have inputs, receivers, you have processors, and then exporters exporting to other systems. And so we're going to look at that in more depth here, and we're going to look at the collector. Initially, we're going to log that. And the way I usually run the collector is as a Docker container. It's really easy to do. To configure the collectors, you are going to use the OTel collector config YAML file, and we're going to look at each of the elements in here. This makes up a pipeline of data from our receivers to our processors to our exporters, so we'll look at each of these individually. But from a pipeline perspective, we can see our pipelines down here, and we have two. We have a traces and we have a metrics, because those are likely going to be going to different systems and being retrieved from potentially multiple sources. So in here we're going to describe our receivers, where we can have more than one, and that receiver we're going to see is the receiver up here. We can have processors, so in this case we're batching it up to help with scalability, so we're not being really chatty on the network. So we have one processor, but you could have multiple processors. You might want to write your own processors if you wanted to make the data more canonical, or you wanted to cache or maybe throw out data that's not important. You can do all that at the processor level. And then export it. Where is the data then going to? In this case, we're sending it to 3 exporters. So here are exporters, Prometheus, Zipkin, and Jaeger. And we're also logging it. So for the metrics one, we're just going to Prometheus and logging. So again, the receivers, we're just going to use one receiver here for OLTP, and we're going to accept both gRPC and HTTP. And our receivers are configured down here in our pipelines. For the processor, we just have one processor, which is that batch one, and it's configured down here as well, but you could have lots of different processors. And then exporters as well here. We have those 3, Prometheus, Zipkin, and Jaeger. We're pointing to where those are running and any configurations it needs. So you do notice here I have a namespace. It's interesting. In my actual one, it says Spring Pet Clinic. I just realized that's wrong. And then we've configured which exporters are going to which pipelines down below. But we could easily add a 4th one, going back to that example with if we had an AI solution all of a sudden come available, we could easily and quickly add that. So what I've done here locally is I do have a Docker Compose file that is standing up both Jaeger, Zipkin, Prometheus, and the collector that is loading that YAML file there. And I did a Docker Compose up, and these 4 things are now running on my laptop. And now I'm going to run the Spring Boot application slightly differently. So I'm going to stop this. There it is. So we're still going to use the OpenTelemetry agent jar. We are going to now expose the tracing, or use the tracing exporter to OLTP, the metrics to OLTP. So that's going to tell it we want to send it to an agent or a collector. We're telling it where that location is. We're going to give it a service name, so it's going to be prefixed with a namespace so we can easily find it in our tools. And then our jar again. And now I'll just execute it a couple times so we have some things to look at. I just realized that to look at the logs, I would have to shut down the Spring Boot. So this is what a canned example looks like, where we can see each of the traces, and we can see the traces have a trace ID and a parent ID that helps us to correlate all those together, and we'll look at that more later. So it's all the same information we got before, just in a more structured way when we use the exporter in the collector. But then the real exciting stuff is it's going to tools, and in this case, multiple tools for the tracing. So I have Jaeger running here, and if I wanted to see what traces it's collected, I could come here, and this is that REST based on the namespace. And if I do a find traces here, we can see we recently had 3 or 4 traces, and if I click on one of those, we can even see the little timeline here. It builds a nice little graph for us. And now we see the trace here. So we had one REST endpoint call, and if I click on this, I can see the details that it collected while that call was going on. That then spawned a MVC endpoint, which called the repository, and then that spawned off a whole bunch of SQL statements. So I might be thinking to myself, well, no wonder it's so slow. We're making so many different SQL statements. And we can see the bars here that are showing the spans, how much time it took for each individual one of those. Now at the same time, because I'm using the collector, I was also writing to Zipkin. So I'll go to another open source tool for showing this information. And I'll run a query here. And I can see how recent it was, how many spans were involved, how much time it took. And if I do a show, I get a similar view with the spans showing here. And if I select any one of those, I can get to the details as well. So we're not spending a lot of time on these tools because that's not OpenTelemetry. It just happens to be a side effect that you'll probably be using some tool like one of those or maybe a commercial product. From a metric standpoint, since we have logging enabled, we will see the metrics in logging. And then we also are going to get this in Prometheus. So I have Prometheus running as well. If I go to Prometheus, here I can do pet clinic and JVM. I like memory, so let's do memory used. And we'll execute this. And we'll see we have different amounts of memory used, like whether it was in the Eden space, the old space, survivor space. And we can also go to a graph and see how that has changed over time. So these were earlier runs. These are more recent runs down here. So again, OpenTelemetry is gathering the data and then shipping the data, but is not visualizing the data. We're going to use some other tool to visualize and do the analytics for it. Any questions at this point? Yeah.
Can you tag the trace ID to the custom log statements as well?
Okay, so a good question. The question is, can we correlate the tracing to log statements? Now remember, right now, logging is not implemented for any of them. That is a future enhancement. But yes, the goal is at that point in time, you would be able to trace it, or you'd have a correlation to those, because otherwise it's really kind of hard to tell. You know, those error messages, were they related to the distributed trace? Where were they? Which also reminds me, one other huge advantage of having this tracing is actually teaching people inside your organization about your own software. So I've seen this multiple times where somebody joins the team, you want to visually show them, okay, this endpoint calls this endpoint, calls this one, calls this. So that's one really valuable way. But another one is, I remember going to production one time and our operations team said, you need to provide us a sequence diagram for every single call you make from system to system. I was like, are you kidding me? By the time I give you that sequence diagram, it's changed 10 times. So this is a live way of providing that sequence diagram as well. And even better, it's live, so if there's a failure, hopefully it points out where that failure is. But your great question about correlation ID leads right into, so thanks for the segue, into context. So context is really important. How are these things related? And so that is a part of the context API and the shared context, which is used by both tracing and metrics and eventually logging. And the way this works is we are going to use those APIs to create a context which will have either a span context or a correlation context. Those get generated the first time it hits somewhere in your infrastructure that is using OpenTelemetry. So if there isn't one, it creates a new one. And then it adds to that as it goes along, much like a distributed or much like a transaction does The first call to the database can then join an existing transaction. Those are passed from system to system using injectors and extractors. So when the call comes in, it extracts it, if it's HTTP, from the header, if it's something like Kafka, from the metadata, and then when it goes to call something else, it injects those into the header or into the metadata so that you can follow it throughout the system. And there's a lot of different propagators. So the last presentation I was in, somebody mentioned B3, which is a Zipkin protocol for doing that. And there's a correlation context that was another quasi-standard. But I'm really excited to say, when I started looking for solutions, when I was scratching my head 2 years ago saying, why is this so hard? Why haven't we solved this problem? I found out that we actually have now a W3C standard on trace context. And I think that was one of the hurdles that we had. So let me explain context a little bit more. In our application, we're ultimately going to have our Angular application called our Spring Boot, which is going to talk to our database. And we are going to want to create spans for each of those. But how do we know that this user's request is all a part of the same thing? That's where this context comes in. And so we are going to create a parent context the first time it gets created, and we're going to add child spans to each of those to correlate those. And then when we go across these boundaries, OpenTelemetry uses propagators to, again, pull that information out and pass it along so that we make sure that it's all a part of the same thing. And like I said, the W3C actually has a standard out now for doing this. It's called trace context. And they do that with a trace parent. And they have a format, which is down here. So there's a version number. Right now, the only version is 00. They have a trace ID, the parent ID, and then trace flags. And then they can use that as a correlation ID through all of the systems to make sure it's all consistent. So we did the Java side. Let's talk about the JavaScript side real quick. I'm not going to go into too much steps since this is a Java conference, but you can see where the API matches certain library versions here. And we are going to use, there's the generic JavaScript library, but we're going to use an Angular interceptor library, similar to the instrumentation one for Java. And it automatically, with a little bit of configuration, knows how to grab all the information and pass the context down to the next level. But if you're using a new framework, you could use the JavaScript library directly if you need to. In order to do this, in our Angular application, we're going to have to add some dependencies. So these are OpenTelemetry dependencies we would add to it. We would add a module for OpenTelemetry, a couple modules, and then an environment so we can configure those. Some environment configurations, we're going to import a log level, and then here in the OpenTelemetry config, we're going to say log to the console too, so we can do some debugging. Production false. We're not in production, so it actually makes it a little bit chattier. It doesn't batch it up by default. We're going to log the body as well, the payload that's going back and forth, so we can take a look at it for debugging purposes. Give it a service name so that when we look it up, it's easy to find based on basically a namespace. And then the log level we've set to all. The other thing we have to do is going back to the collector configuration, we have to enable cores because it's not, the JavaScript's not going to be able to call that endpoint. It's going to fail. So this is not a best practice on security. I have it all opened to make it easy for the demo. And now with the agent running, going to the collector for the Java side, and now with those configurations done inside of my Angular application, so I'm pulling the cake out of the oven. I already made those changes. You didn't want to watch me do that, I'm pretty sure. If I go to my Angular application now, and as I go through the application, doing things, searching for things, it is collecting all that data for me. So if I go back to Jaeger, and I change this from REST to client, because that's what was set in my Angular application, and I do a search or find now, we now see that I'm getting HTTP endpoints that have both a client and my REST endpoint. And when I click on this, we can see the yellow is what's happening in Angular, and the green is what's happening on the REST endpoint. And this can go on to Kafka and other things as well. What's happening underneath the covers is with each of the requests, it's using that W3C standard. So we see the trace parent here with that format that we talked about. It is also, just to be sure, it's also adding an Uber trace ID, which is some other product probably, this Amazon one that's for X-Ray, and the B3 ones that I already mentioned are for Zipkin. So it's sending a bunch of headers to make sure that whatever's receiving it can participate in that transaction. If we look at the information it's passing, so that's passing with each request. This information is being sent to the agent, not to the REST endpoint, but it's the details we would want to know. So that trace ID again, so we can correlate it. The URL, what schema, what endpoint, user agent, the status code, so it was successful. It's even giving us the payload if we configure it that way as well. So that shows connecting multiple systems together. Yes?
Suppose in real-time production, my Angular app is connecting to two services, right? It's connecting to one service and that service is connecting to another service. So can I have a uniform trace ID from Angular to one service and that service connects to another service? Or
yes.
The trace ID will be different for each request?
So if your Angular application is calling one service and that service is calling another service, you're going to have the same trace ID, and then there's going to be a separate span ID in addition to that, so that you know each span or each part of it, whether it be another system or libraries within a particular application.
Then I can use my log aggregator to check that trace ID, right? You know.
So you said log aggregator, and again, at this point in time, logging is not a part of OpenTelemetry, but once that happens, yes, you'll be able to correlate that trace ID to the logs and bring them together. And once we have that all implemented, we will have the true vision of or observability as opposed to just monitoring. Yeah. Other questions? Okay, so at this point, I've showed you using the Java library just through the agent, but what if you want to trace things that are not already traced, that are not a part of that instrumentation library? Well, that's what I'm going to show you right here. So we have the tracer API, we have the tracer implementation, and we have both a span processor and span exporter. So again, we're talking about this logical and service layers. It's relatively simple to do. We added dependency of the annotations. We can either do it with annotations or we can do it more direct calls, but I'm going to show you the annotation way because that's probably where you're going to start. So if you want to add a new span to an existing trace, all you need to do is add a with span annotation on any method, and that is going to then add a new bar down here on your, so in this case, this is the Jatson custom owner serializer. We can see down here, we now have this included in our, as a span inside of our trace that we did not have before. So that's an easy way to add any method to the list. Now you might want to add some additional data along the way, and to do that we can do a span, getting the current span, and we can add attributes. So in this case, the last name of the owner that was searched, and then that will show up down here in the metadata for that particular part of the span. So really easy to do with annotations. Metrics, unfortunately, we don't have annotations, but we can still add custom metrics if you wanted to add counters or gauges specifically for business data. So we can use the meter API and then the implementation classes here. For this, we're going to add a dependency to our dependency manager of the PALM for the BOM, and then we're going to add specifically the APIs that we need. And now there's a number of ways that we can get OpenTelemetry, but we're going to use the global one here to get a meter. So we can name our meters anything we want to name them. There's a number of different meters that are optional to us. We can use gauges, which are value at an instance. We have counters that will add up and decrement. We have up and down, so counters have to be positive. Up and down can be positive or negative. And we have histogram data as well. Those are the options that we have. So this one happens to be a counter. So using the meter, we say we're going to use the builder pattern. So we're going to use a counter builder. Specifically, we're going to count processed jobs. We can give it a human readable description. The unit is going to be, we're adding 1. So other things might be milliseconds or other types of units. And then we're going to give it the value. So we're adding 123 to wherever the current value is. And we can specify metadata as attributes. So this will happen as soon as this is called. We'll be adding that. But a lot of metrics you probably want to do asynchronously, right? You want to grab that data in the background while the application is running. You can do that as well. Basically, everything is the same until you get to the build. And you do a build with callback, passing it a lambda. And then this lambda is going to be called on certain intervals, which you can configure here as well. So you can add whatever metrics you want. For integration, we have a lot of different points for integration. We can integrate propagators, we can do span processors, we can do span exporters, we can do aggregators and metrics, and we can also use those same span exporters and metric exporters in the collector as well. And this is where you can support things like Kafka, or if you have your own protocols that OpenTelemetry can't know about, you could implement your own. But they also have a registry where you can find lots of existing ones and search based on language or type, whether you wanted a propagator or an aggregator. And you should take some time and look at it. It's a very, very long list and always growing because more and more of the vendors support. So any questions before I go through my summary? Well, I was so ecstatic to find that OpenTelemetry was coming 2 years ago and is really ready for production, at least on the tracing and soon for the metric side. And I wish it would have been there. I don't know why it was so hard to do what we did 2 years ago. And now with things like F5 being involved, I don't have to look at PCAP files, hopefully ever again. Thank you. And I'm going to be able to correlate everything. That whole effort could have been done probably in hours instead of 2 weeks. When I started doing this presentation, the only real resource I could point you to was the documentation itself, which is decent. But now there is documentation and better support coming out. So there is a dzone ref card that's really good you might want to check out. Their examples are in Python. That's the only negative thing I can say about it, but it is a good resource. A book has recently come out called Cloud Native Observability with OpenTelemetry. So that's the first book I'm aware of. And then there's also a report called The Future of Observability with OpenTelemetry. And this individual has put together a really nice GitHub page with a lot of great resources of books that are either exactly on OpenTelemetry or related to OpenTelemetry, videos, blogs. So you might want to check that out as well. So all of my slides are available right here, so feel free to take a photo of the QR code or grab that URL and go get those. Questions? Well, thank you so much for spending your afternoon with me. I hope Jconf goes well for you the rest of the time. Feel free to come see me during the event tonight. I'd be happy to talk to you more about this. And have a great time. Safe trips on your way home as well.